My name is Dave Roberts. I work for MOTU. We got some really cool stuff that we're going to be talking about today. MOTU has just released a new generation of audio interfaces equipped with AVB technology, along with the industry's first low-cost 5-port AVB switch. These interfaces have been shipping since July. These products are now mainstreaming AVB Ethernet in broad segments of the pro audio market. They have an affordable price tag, compelling and complementary I/O configurations, ultra high quality analog performance, extensive 48-channel internal mixing, DSP effects processing, and universal computer connectivity through Thunderbolt and USB. Perhaps the most exciting news about these new interfaces is their implementation of AVB networking technology. These are the industry's first audio interface products to bring AVB to everyday studio workflows. We consider this technology to be the future of audio connectivity and transport. In this presentation, I will show you how you can have 512 or more channels of high-quality audio, all networked, all available, easily controllable, and with extremely low latency. Then we'll discuss how you can put these amazing capabilities to use in your everyday studio workflows. First of all, we're going to get started by talking about the actual interfaces. We've got 3 new models of interface, and the first interface I'm going to show you is the 1248. So let's take a look at the 1248. We'll start with the back panel. The 1248 has 4 built-in microphone preamplifiers. These are entirely new mic pre-circuits from MOTU and have exceptional audio quality. We've built these interfaces from the ground up. This is not a rehash of last generation technology. This is all new technology from MOTU. The 1248 has 12 channels of line-level analog input and output. Line outputs provide up to 20 dBu full-scale signal, and the inputs will accept up to 24 dBu of input gain. The inputs and outputs can also be calibrated for other reference ranges, such as -10 dB. All gain settings, including preamp gain, can be remotely controlled and saved as presets. On the front panel, the 1248 has 2 high-Z guitar inputs and 2 sets of stereo headphone outputs. We take a look further along the back panel. For digital I/O, the 1248 has 2 sets of optical ports and SPDIF I/O. The SPDIF I/O supports real-time sample rate conversion. You can also see the BNC word clock ports, Thunderbolt and USB connections for the computer. The USB connection is class compliant for iPad compatibility, and there's the AVB Ethernet network port. So that means in total, the 1248 has 32 discrete channels of audio input and 34 channels of output. That's 66 physical channels of audio I/O, and all these channels are available simultaneously. Now we'll take a look at the front panel. Here we see the master volume control for the main and the monitor outputs. That's followed by 2 independently assignable headphone outputs and the high-Z guitar inputs. Next up are the mic pre-controls. Separate phantom power and pad controls for each pre. The preamps provide 63 dB of available gain. All of these preamp settings can be controlled remotely, even wireless over Wi-Fi, which we'll discuss more as we go along. These 4 knobs also function as programming buttons for the interface. The LCD display shows all of the audio input and output levels, including the digital I/O. And all the way to the right of the display, we see the current sample rate and clock source settings. Now, if we're going to talk about audio interfaces, I think the first thing we need to talk about is the sonic quality, the analog input and output. So let's take a look at the numbers here. The 1248 operates up to 192 kilohertz sample rate. Take a look at the numbers. 123 dB of dynamic range on output and 117 dB of dynamic range on input. 24 dBu of full-scale input, 20 dBu of full-scale output. That includes the microphone preamplifiers on that 117 dB of dynamic range. The equivalent input noise on the mic preamps is -128 dBu. These interfaces have been shipping for a couple of months now. Talk to anybody who's got one in their studio. The word is getting out. These interfaces sound absolutely great. So I would say the first point to make about these interfaces is the sonic quality. No compromise audio quality on these new interfaces. Okay, the next model we'll talk about is the 8M. The 8M has 8 analog inputs and 8 channels of analog output. Each of the inputs can be configured as a line input or mic preamp. So the 8M gives you a potential of 8 channels of mic preamps on board. Each preamp has an available preamp converter hardware limiter. The left side of the rear panel is similar to the 1248, which we just discussed. That includes 2 sets of optical I/O, word clock, USB, Thunderbolt, and the network connections. On the front panel, we see the headphone jack and volume control, followed by the mic preamp trims, pad, and phantom power controls. The 8M has 123 dB of dynamic range on output. The mic pre's with their hardware-driven V-limiters have 112 dB of dynamic range on input, and again, the equivalent input noise of 128 dBu. If you need a lot of high-quality microphone preamplifiers, the 8M is the way to go. The next interface in the new line is the 16A. 16A is all about analog I/O. 16 channels of balanced line-level analog input and output, and we do complement that with another 16 channels of optical input and output. There's your computer and network connections. On the front panel, complete metering, analog, digital, sample rate, clock source, all right there on the front panel. And we'll take a look at these audio specifications. 123 dB of dynamic range on the output and 117 dB of dynamic range on input. Absolute top quality audio specifications. So that's what's going on the outside of these new interfaces. Now we're going to take a look inside. The MOTU AVB interfaces have incredibly powerful internal routing and mixing capabilities along with studio-grade effects processing. The new models have roughly double the amount of processing found in our previous Mark III interface line, with an entirely new 48-channel mixer designed after large format mixing consoles, plus an updated arsenal of effects. New effects processing, new mixer, and we'll get into that. Now, latency performance is critical. That's the question that everybody asks about, and the MOTU AVB interfaces clock in with a total round-trip analog input to analog output latency of just over half a millisecond when operating at 48 kilohertz sample rate. That's including with effects processing. At higher sample rates, the latency performance is even better. So now's the time to take a look at some software. All right, what you see running over here is the Google Chrome web browser, and that's hosting the MOTU AVB app. When you plug your computer into the AVB interfaces, or even if you don't have a computer, let's say that you've got an Ethernet network or a wireless broadcaster, an airport broadcaster, the control of these interfaces is done through a web server. All right? So all we need to do is connect up to an Ethernet web server, launch our browser, and that means that we can run on Macintosh, Windows, Linux, iOS, even Android. Anything that will run a web browser will give us access to the control of what's going on inside the interfaces. So we start with the device page. We can save presets. I'll go up here to my preset browser. We give you a number of presets to get you started. The presets are stored inside the interfaces, and there's memory inside the interface for up to 100 presets. So you configure these interfaces the way that you like. You can call up the presets from the front panel of the interface. So if you're setting up the interface to be a standalone converter or a digital snake, for example, you might not be using a computer. You might not even be using any sort of internet access or web access. You might just configure the interfaces from the front panel and call up those presets from the front panel. Then we'll go to the routing page. And what the routing page is all about is this is where we see our inputs and outputs. And we have a routing grid. And what we see along the top are inputs, and what we see along the left-hand side are outputs. There's 3 families of inputs and outputs, 3 types of inputs and outputs to our AVB interfaces. We have inputs and outputs on the interface itself. I've gone through the 3 interfaces, and I've showed you the microphone preamplifiers, the line level connections, the digital connections. So you have inputs and outputs on the interface itself. Then you have inputs and outputs to the computer. That's through the USB or the Thunderbolt connection. And then you have inputs and outputs across the network. So 3 families of inputs and outputs, and this routing grid will see all of those inputs and outputs, and this is what allows you to make the connections through the interface if you're using it as a routing box, and also if you're using the internal mixer of the interface. So the next page I'll take you to is the mixer itself. And here we can hide or show, because you can get into some very big configurations here. You can have 48 channels of input into this mixer. For outputs, we've got main outputs, monitor outputs, 14 channels of auxiliary output, 4 sets of stereo group outputs. For effects processing, high-pass filters, gates, EQs, different types of compressors. We can save presets, so you can have your mixer configuration that shows only the inputs and outputs that you currently need to work with. This can be a very large, complex system, or you can simplify it to show only what you actually are working with at the current moment. So this is the MOTU AVB web app. This is the control for your MOTU AVB system, the entire network. And again, this is running on a web browser, so this will run on any device that will serve a web browser. Could be an Android device, it could be an iOS device, Linux, PC, Macintosh. Any type of device that will run a web browser will allow you to control this. Also, for additional remote control, one of the things that we've recently introduced is OSC control. So if you want to have a separate control, we've got OSC access and full documentation for that. So that's the software that's being used to run the MOTU AVB system. Now let's take a look at the network port. This is where the real magic of the MOTU AVB system comes in. First of all, the network port on the interface can be used for connecting external control. I can connect it directly to an Ethernet network. I can connect it to some sort of wireless broadcaster. I can connect it to my computer via Ethernet if I like, but that's how I can get into the device. And again, I don't even need a computer. If I'm using a wireless broadcaster and my iPhone, for example, I've got complete control over what happens in all of the interfaces that are connected to the network. The Ethernet connection, the network connection is excellent. If you are actually connected to the World Wide Web, if you're connected to the internet, the interface will communicate with the MOTU home servers. If there's firmware updates available, they can be downloaded. You can update your entire system from a single control point. You might have a large distributed system. If we come up with a firmware update, new capabilities for the hardware, new device presets, then the interface will phone home and download the update and away you go. Another thing that we can do with that network port is we can start to connect multiple interfaces. So far what we've been talking about is really a computer connected to an interface, and that's a very simple thing of input and output to the computer, an audio interface and a computer for recording and playback. But this new AVB system will do so much more than that, and the expandability through the AVB is really the key. So if we have two interfaces, we can do a simple connection using Cat5 or Cat6 cable, and that's exactly what I've got going on here. I've got my computer connected to one interface with a Thunderbolt connection. I could also use a USB connection if I had an older computer, but the two interfaces that are in the rack are connected to each other with an Ethernet cable. Those Ethernet cables can be up to 100 meters in length. So think about that. Now we can start to have the interfaces up to 100 meters apart from each other, so we can have a distributed network. We'll talk more about that as we go along. Let's talk about AVB. AVB is an industry standard Ethernet protocol. AVB stands for Audio Video Bridging. Think of this as a high performance, low latency Ethernet for pro audio. AVB works much like Ethernet. It uses the standard Cat5 or Cat6 cabling. It uses a standard AVB switch for network expansion. It's reliable and it's very simple to use. So now is probably the time for me to introduce the fourth product in our line. This is the AVB Switch. You see me holding this here. And the AVB Switch has 5 AVB ports. It has an extra 6th Ethernet port for patching to an Ethernet network. 1 gigabit capability. It's one of the lowest cost AVB switches currently available on the market. And again, I want to emphasize that AVB is an industry protocol. This is not a proprietary MOTU protocol. AVB is an open standard protocol, and there's a growing list of companies that are getting involved in AVB. This is very cool stuff. So what the AVB switch allows us to do is to start to grow the network. All right, so a single AVB switch will allow me to connect up to 5 MOTU AVB interfaces into a single network. Now we see the system start to scale up. In addition to creating a network of audio I/O, routing, and DSP power, each interface on the network can be connected to a separate computer via USB or Thunderbolt. So the AVB switch is like this star that connects all the interfaces to each other. And remember now, those interfaces can be up to 100 meters apart from each other. And then all we need to do is start patching in computers. And we can have computers at every point in the network. And every one of those computers sees all of the inputs and outputs, all of the DSP processing. They see each other, the computers see each other, all through this AVB network. Then we can take it a step further. We can use multiple AVB switches. Each switch will support up to 4 interfaces, and the switches connect as repeaters. So we can go past that 100-meter cable length. We can have up to 300 meters of cable between connected interfaces. This allows us to create a large distributed audio system. Let's talk a little bit more about AVB. As I mentioned, it's an open industry standard, a growing list of companies developing for this protocol. There's a lot of good reasons to go with AVB. First of all, hundreds of channels. We've tested up to 512 channels of audio running through a single MOTU AVB network. 512 channels of audio through one network. It's really easy to use. You just plug in the cables. You don't need to be a network or an IT professional to use this. Every interface that you plug into the system is instantly recognized by the system. Now, the AVB specification says there can be no more than 2 milliseconds of fixed latency delay throughout the entire system. That includes the entire network. That's a maximum figure. It's a fixed figure. You'll never get more than 2 milliseconds of latency through an AVB system. Actually, MOTU has improved on that performance. I'm going to show you that in a moment. We fine-tuned the AVB specification to get the best possible performance. So I'll talk more about this as we go along. But another good thing to know about AVB is it's got what's called guaranteed quality of service. What this means is there's fixed bandwidth for available audio signals throughout the network. So if you add on another piece of equipment, you're not going to steal bandwidth from equipment that's already part of the network. You have guaranteed performance all the time, all the way through the system. It's a hardwired system. It's a level 2 hardware system in the switches and the various devices that are plugged in. Rock solid, reliable. Talk about synchronization. AVB was designed from the ground up to provide a unified clocking and synchronization system. In simple terms, all the devices on the network follow a single grandmaster clock source. Clock can originate from any interface on the network or from an external source. The MOTU AVB app makes this super easy. You can designate the clock source for the entire network with a single click. Think about that. You have a large distributed audio system, you have interfaces in different rooms throughout a building, and for whatever reason you need to change the clock source of the system. With a single click in the MOTU AVB app, and remember that AVB app can be running on a computer that's connected anywhere throughout the system or a wireless network. One click and you reconfigure the clock source and the sample rate of the entire AVB system. Also, AVB clock is about as stable as it gets. The precision is measured in nanoseconds. AVB time is more than 1,000 times faster than the word clock signal because this is audio and video bridging. It's a video standard as well as an audio standard. So rock solid clock throughout the system and very easy to manage that clock. Additional benefits of AVB include connection to a standard Ethernet network. You can have very long cable runs. You can patch into an existing Cat5 or Cat6 cabling system. If you've got a building that's wired up with Cat5 in the wall, all you need to do is swap out the Ethernet switches for AVB switches, and now that building is wired up for an AVB audio network. But I did talk about how MOTU has fine-tuned the performance of the AVB audio specification. So let's talk about some of the things that MOTU has done within that AVB spec. First of all, we give you connection to the computer directly, either through Thunderbolt or USB. Those connections are right on the interface. So we don't need another piece of hardware to connect our AVB network to the computer. Every single interface can be connected to a separate computer, and all you need is the USB or the Thunderbolt cable to do that. We have 256 channels of audio passing in and out of every computer connection. 128 channels going in, 128 channels going out, and through the network itself, we can do at least 512 channels of audio through that AVB network. Each MOTU device on the network can broadcast or talk 128 channels to the network, and it can receive or listen to 128 channels from the network. So again, think about the possibility here. You have multiple interfaces spread out wherever. Maybe it's a sporting event. Maybe this is a recording studio where you have multiple rooms. Maybe it's a building that you have to have audio in different rooms. And you can have computers in all of these locations. Every part of the system sees every other part of the system, and each one of those computers has 128 channels of audio going in and out. As we start to expand the system, it just gets more and more powerful. Each interface has its own internal 48-channel mixer with effects, and when I showed you the AVB app, you see that you can control all of those mixers from a single point. Those mixers are integrated with each other through the network. So when you have a network, as you add interfaces on, each interface that you add to the network adds inputs and outputs to the network. It adds mixing capabilities. It adds more effects processing, more DSP power. So for example, if I want to plug microphones into one interface and then use a different interface for EQ and compression of those microphone inputs, I can do that. I can fly signals around the network, and this network is really one unified audio system. Now remember, the AVB specification, all right, the standard specification says there can be no more than 2 milliseconds of latency throughout the system. But with the MOTU system, we've got it down to 0.6 milliseconds of fixed network latency. So we've actually, as I said, fine-tuned that AVB specification and got it down to 0.6 milliseconds. Let's see how that works. Remember earlier I showed you that latency through a single interface is a total of 32 samples from analog input to analog output. That's on one box itself. Now if we start to connect additional interfaces, we get the additional network latency delay, which with our system is 30 samples at 48 kilohertz. That gives us 1.29 milliseconds of delay from analog in through the network to analog out. That includes effects processing in all the interfaces. That includes these long cable runs, multiple switches, 1.29 milliseconds of delay from analog in to analog out, and that's at 48 kilohertz. If we go up to 96 kilohertz sample rate, the converter latency is lowered, and the number drops even further, and we get a delay of 1 millisecond from one end of the network to the other. The network delay of 0.06 milliseconds is 3 times better than the maximum AVB 2 millisecond delay specification. So MOTU has really tweaked what AVB is capable of here. Now take a look at this system. We see multiple interfaces connected by multiple AVB switches. We could connect a separate computer to each interface on the network. I talked about how there are 3 general categories of inputs and outputs. There's I/O from each computer, there's I/O on each interface, and there's input and output distributed throughout the AVB network. Every point on the network sees every other point on the network. Signals can be routed amongst computers, amongst interfaces. They can share DSP and mixing. You can control the entire network from multiple devices, laptops, tablets, smartphones, anything that will run a web browser. So the MOTU AVB system is easy and powerful to use. It's as simple as, well, if you have 2 interfaces, you don't need to switch. If you have 2 interfaces, you use a Cat5 cable. That's what I've got running on the desktop here. If you start to expand 3, 4, 5 interfaces, you can go with a MOTU AVB switch. If you need a larger system than that, you can use multiple switches, and all you do is just plug everything in, and the entire system sees every other point on the system. It's very easy to use and set up. So to sum it up, the interfaces that we've showed you represent the future of connectivity and with complementary I/O configurations, stellar audio quality. All right, that's the first thing I talked about was 123 dB of dynamic range, 24 dBu of input, 20 dBu of output. I don't think it's worth talking about audio interfaces unless you have the absolute top of the line converters. We're using Sabre 32 converters on these interfaces. They've been shipping for a couple of months now. Go up on Gear Sluts, which is generally a pretty hazardous place for a company to advertise its products. There's a 40-page thread up there, and the people that have this interfaces that are posting up there are saying, we've compared this to top end, I'm not going to mention any brand names, but top end interfaces, and the MOTU is on a par or better than any other converters that are currently out there. These interfaces sound absolutely great. We've got the mixing capability, we've got the DSP capability, we've got the AVB audio networking, we've got the AVB app, the web app for controlling the whole system, and it can even be done wirelessly, and you can have multiple control points happening. So the 1248, the 8M, and the 16A interfaces are $14.95 each. The switch is $295. Again, if you compare the other products that are out on the market, MOTU has hit another home run with quality to value. The interfaces are not expensive, but they are absolute top quality, and that includes the AVB switch, and this is a standard AVB protocol switch. Talk a little bit about applications. All right, we'll start with something very small. Maybe we're going to use the MOTU, single MOTU AVB interface with a computer. Plug it into your iPad if you like. You've got top quality conversion in and out of the computer. You've got the zero latency mixing on the interface itself, top quality audio effects all ready to use. If we want to go to a large format studio, we can have interfaces that are up to 100 meters apart if I'm just using two interfaces. So let's say I've got a control room and I've got a recording room. I can have computers at both ends of that network. So in the control room, right, there you are as the master engineer recording everything that's going on, and the musicians that are in the recording room, they can plug their computer in and they can be getting the same feed, so you can simultaneously record all of the signals to multiple points. And then if you need more than two interfaces, you get yourself an AVB switch and you continue to expand the system there. I mentioned that you don't even need a computer. Really, the purpose of the computer is for recording and playback, but remember now, these interfaces have mixers and effects processing inside. You can have very long cable runs, so you can use this as a standalone mixer system. Maybe we've got interfaces on stage, we've got interfaces at the front of house position. The front of house mixer is doing a front of house mix. Musicians on stage are doing their own monitor mixes. Multiple control points, very easy to use, and patch computers in if you need to record, patch computers in if you need playback, patch computers in if one of the musicians on stage is using virtual instruments for playback. So computers can serve different purposes. They can be patched in and out of any point on that system. This is a graphic showing a stage I/O, right, an Ethernet snake, if you will. So what we're showing here is actually a very simple system. If you need inputs and outputs on stage, inputs and outputs at front of house position, or anywhere else, any other application where you need to run a lot of audio signals over a long cable run, you don't even need the control app to do that. You can set up your presets on the interface, hook the interfaces up, hook up your Cat5 or your Cat6 cable, and now you have that digital snake. So a few other networking scenarios. We'll start small. Personal studio, top of the line input and output, 3 different interfaces to choose from. You can expand on that if you need more inputs and outputs or different varieties of connections, need a lot of microphone preamplifiers. Maybe you'll go for a couple of 8M interfaces. Need a lot of line level analog input and output. You'll take a look at the 16A interface. As you get into a large format studio, maybe you're going to have interfaces distributed throughout the studio. Maybe you have multiple control rooms, multiple recording rooms, and all of the inputs and outputs throughout the entire studio are all available as part of the same network. You can have different sessions going on, and then if you need to patch this isolation booth into that control room, it's just a question of going in and configuring those connections. Live performance venues. Right, with these extra long cable runs, so sporting venues, that type of thing. Security installations. You know, we come up with technology, we come up with products, and then we start getting phone calls that we didn't expect. Somebody says, can I set this system up so that I've got multiple microphones around the perimeter of a building that I can all monitor from one central point? I said, sure, you can do that. What's your application? Well, we need a security system, no problems. Houses of worship. All right, churches have amazingly complex systems now. If you think about it, you have the person that's speaking on stage, you have musicians, you need multiple monitor mixes, you need a front of house mix. At the same time, you might be doing live 2-channel broadcast, you might be doing multi-track recording, you might have several different places where mixing is going on, where recording is going on. And the MOTU AVB system is just going to fit right in there. Just decide what inputs and outputs you need, where you need them, wire it up, give the control to whoever needs it for monitoring, for mixing, for recording, for playback, easy to use. Schools. Perhaps you'd like to, most schools now are wired up with Cat5 cabling, so now you can move the interfaces around from room to room if you like. Government installations, a strong market for us. Now we're getting out of the realm of music, but a courthouse, for example. In a courthouse, you've got multiple rooms where there's going to be microphones and multiple microphones in each of those rooms. And maybe you're going to do some recording in that room, but maybe you've got a central recording spot somewhere in the building. So the whole building gets wired up with one unified system, and the MOTU AVB system will do that. Corporate installations, same type of thing. Large distributed audio network. So there's our three interfaces. These are the first three AVB interfaces shipping from MOTU. That's the 1248, the 8M, and the 16A. Studio grade processing, stellar audio quality, and the latest AVB networking technology. Ladies and gentlemen, I am so proud to make this presentation to you. I'm so grateful for you staying at the last minute on the last day of the show. Thank you very much. I'll stick around.